Okay, so just giving you a heads up on page 27, probability, guys, probability is still favorable over total. It doesn't change. What changes today is there are two types of probabilities. There's something called experimental probability. It's based on trials, experiments, or surveys. Okay? So, how do you know it's experimental? Something happened. Someone actually kept track of the experiments. So, let's say one of the assignments is, okay, I want you to roll the die 100 times. Record 1, 6, 2, right? So you're recording. You're doing an experiment. You're actually keeping track of your results. That's when we have the total number of trials underneath. So it's still favorable events over total number of trials. Can you write down total? Because I don't want you to forget that. Total number of trials. Let's do a quick experiment actually, just so it kind of you see at firsthand what I mean here. Tell me, what's the probability of rolling a 1? What is it in real life? Like based on this die, what have we been answering? 1 over 6. Is that theoretical probability or experimental probability right now? It's theoretical. We haven't done an experiment yet. So I would go ahead and say theoretical probability of rolling a 1 is 1 out of 6, right? Let's do our experiment now. I'm going to roll this 3 times. I'll do a bit more. I'll do 10 times. And just to let you know that it doesn't have to be the same denominator. You can do this experiment 100 times, it doesn't matter, okay? So let's record how many times we get a 1, okay? You're gonna be my witness here. So I'm gonna record my results, okay? 2, 2, 5, 2, 6, so 5 already, right? Keep going. 6, I know it was a bit of interference. I got 6 again. I got 2. What's going on with 2? And I got 2 again. I got 2 again. What's going on? Is this very accurate? Like you can tell, this is just, I kind of like that this happened. 1, 2, 3, 4, 5, 6 times we rolled a 2. Can we rely on these results? Like are you expected to see that many 2s in real life? If I rolled 100 times, you think things are going to change? Yeah. So right now, this is a small number of trials. That's the problem right here. But what's the experimental probability of rolling a 1? 0 out of 6. What's going on here? That can't be, right? 0% chance of getting a 2? No. So there's something, this is where I need you to understand something, okay guys? Theoretical probability, this is what we're expecting to see in the long run. Okay, this is what we're expecting to see on the long run. So even if you rolled 1,000 times and you got your results, it would probably reduce to 1 out of 6 for rolling a 1. It would be the same answer for rolling a 2. It'd be the same answer for rolling a 3 and so forth. So they're not always the same because it's a small sample size, that's why, okay? So we're gonna address that in a bit. So I have 2 different colors, orange and green. Experimental probability is based on total number of trials. Theoretical probability, it's the total number of possible outcomes. Let's put total there as well. I don't want you to forget that. That is always true. So can I just add something to this box here? you should see results of trials. That is important. You should see them somewhere, or they will state what actually happened. Okay? Another way of thinking of this, but I don't want you to use it as a way of explaining, but this is based on what happened, and this is what should happen. So this is kind of like what actually happened, and this is what technically should be happening in the long run. Let's keep going. This is worth highlighting, the whole thing. This is a very important concept. If there's a small sample space, right, you're not going to have accurate results. But remember, guys, theoretical probability is king, right? It's, most of the time, it's the one you want to mimic. So small sample space, experimental will not be equal to theoretical. But once you do more trials, so let's write down more trials. If you do more trials, you should observe that the experimental probability is approximately the same as theoretical. Okay, they should be very similar to each other. Okay, and another one worth highlighting: when you're making a prediction and you know both probabilities, for a prediction, you want to be using theoretical probability most often. Most often. And you're like, what do you mean with most often? How many types, how many blood types are there approximately? Is it 8? 7 or 8? Okay. Is it fair to say that I can just randomly grab a student and say, like, the chances of you having a blood type is 1 in 8? Is that accurate to say? Or is there one blood type that is more common than others? There are some blood types that are far more common than other blood types. There are some that are so rare, it's like 1 in 1,000, right? Or 1 in, like, only have that blood type. So that's the one instance where experimental probability is what you want to use to make a prediction, okay? Because it's just not something that is randomly attributed, okay? Keep going. Okay, so here's a classic. A bag contains various letters as seen below. Let's make an arrow, because sometimes students think it's this right here. I mean the bag right there. Alex draws a tile, records the results, then places the tile back in the bag. This process is repeated 8 times. Here are the results. These are the trials. Okay? These are your results of your experiment. So you should right away be thinking, oh, I bet you it's going to be experimental versus theoretical probability. That's the difference that we're going to have to determine here. So state the experimental probability of drawing the letter A. Will we go by the bag, or will we go by the results? The results. So 1, 2, 3, 4, 5, 6, 7, 8 trials. Or draws. You can write down draws if you want. And how many times did it land on, or did we get the letter A? 1, I'm going to circle 1, 2, 3 times, right? So 3 A's were drawn. Let's write this as a decimal. 3 over 8, 0.375, or 37.5%, right? Now state the theoretical probability. When it comes to theoretical probability, you want to go to the item that has been used to make these experiments, to produce your results. So we use this, right? So we will go, theoretical probability would be how many tiles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tiles. So there's 10 possible tiles that you can draw from. And how many of those are A's? 1, 2, 3. 3 A's. What's 3 over 10? 0.3. Multiply that by 100, you get 30%. So it's different, right? The answers are not the same. See that? Why is the experimental probability than the theoretical probability? Explain. This is mainly due to the low number of trials. Okay? Alex should increase okay? If Alex draws 500 tiles, how many times would you expect to draw the letter A? You're making a prediction. Prediction of drawing an A times 500. Which probability are we going to use to make our prediction? Some of you might say, well, obviously, Mr. Dirksen, based on what happened, no. You want to use theoretical because that's what we are expecting to happen in the long run, okay? So we go 3 over 10 times 500. That's 150 times exactly. And let's highlight this though. The 3 over 10. Let's highlight that up here. We use the theoretical probability. I will actually use theoretical probability to make a prediction. Okay. If you go back to our experiments, guys, earlier, if I had just taken the first 2 trials, the probability of rolling at 2 would have been 100%, right? It's not accurate. If you increase it a bit more, now it's 67% because it's 2 out of 3, right? The more samples you have, the better. Just like the Amazon reviews or any review, if there's only like 1 or 2 reviews, should you trust that, the results? No. Once you've got like hundreds or thousands of reviews, now you have a pretty good sample size. Now you know it's probably, like if it's a 4.5-star review and there's 10,000 people reviewing it, you can trust it, right? State the experimental probability of drawing the letter B. Experimental. We're gonna go to 8, right? We took 8 tiles in our experiment, and how many were B? Only 1 time did it land on B. Okay, I'm going to leave it like that. That's the probability. And the odds, I'm reviewing, going from probability to odds. This would be 1 to 7. Because remember, they add up to the 8, right? State the theoretical probability of drawing the letter B. Theoretical probability. I usually go TP. Let's do that here. EP for experimental probability, TP for, and when it comes to theoretical, we're going to the bag where we know we have 10 tiles. And how many of those are B's? There's 2 B's in there, right? If you wanted to turn this into odds, you would go 2 to 8, or 1 to 4 if you want to reduce that. I will write that down because that is important in case it's a multiple choice and you need to select the right one. We have that, okay? Let's keep going. And then I'll ask you to work a little bit yourselves. Let's go to 29. George flipped a coin. Here are the results. Results. You should be thinking experimental. It's based on the experiment, right? State the theoretical probability of a coin landing on tails. Let's see if you're awake. Just in case you still need to wake up. We're talking about this coin, right? Imagine there's a picture of a coin on this side, and these are my results. What is the probability of it landing on tails, of this coin landing on tails? Theoretical. We're going to go to the coin, right? It's 1 and 2, right? There's 2 options, like there's one side and the other side, heads, literally a beaver tail, right? Heads or tails. So there's 2 options, and one of them is tails, so that's it. Okay? Experimental probability is going to be different. We're going to go look at our results. How many trials did we perform? How many times did we flip the coins here? Yes. So this is our combined, is going to get us that, right? We're going to get our total trials. And landing on tails, we're going to take the 240 and put it up here. So this is 240 over 400. Don't reduce today, you just make sure the numbers that you select are correct, okay? So, and if you're highlighting, the 240 came over here. And I will just make sure, right, over here maybe, just make a note, 160 plus 240, there were 400 trials. If you're writing that down, then you know where the 400 came from. So please don't mix them up. I would actually, if you can draw a coin here, I'm just going to do that. I'm not going to draw, right? But we used the actual coin to answer the theoretical probability, and for experimental probability, we went back to our results. Okay, so that is the important thing here. That is the gist of my lesson. If you toss the coin 1,000 times, how many times would you expect it to land on tails? You're making a prediction. We would go probability of tails times 1,000. Which probability are we going to use? This one or that one? We're going to use that one. We're going to use the theoretical probability. So this is going to be 500 times. So half of the time we expect it to land on heads and half of the time on tails. All right? So I'm gonna ask you to, we're gonna work, basically it's all fair game all the way to 35. So I'm just gonna go page 29 to 35. I would really want you to at least get everything up to 31 or 32 done. Okay, so there's your homework. I have a deck of cards. It's a deck of cards, right? Or these are cards, right? What was used to perform those results? A full-on deck of cards. So if you can imagine a picture of a full deck of cards somewhere on the side here, that is where we're going to take our theoretical probability from. This is for experimental probability, right? 5 cards were drawn and the results were recorded, so make sure you don't mix them up, okay? All right, give it a go.